Okay, we're going to look at the idea of scientific notation, which allows us to write a number with many digits in a somewhat shorter form. The idea uses powers of 10, and it could be negative powers of 10 or positive powers of 10. For example, if I'm looking at the number 2000, I can write the number 2000 as the product of 2 and some power of 10. So we can say 2000 is really 2 times 1000, and then we can take the 1000 and write it as 10 to the third, because 10 to the third is really 10 times 10 times 10, which gives me 1000. So we have it broken down as 2 times some power of 10, and often for scientific notation use the notation of an X or a cross for times, like you used to do in grade school. So this is the scientific notation basically for the number 2000. Now 2000 is not a number with a lot of digits, so in scientific notation it doesn't save us much space, but a bigger number would actually save me more space if I put it in scientific notation, and you'll see shortly. So we looked at 2000, let's look at another number, 0.0002. Well, if I'm looking at this number, let's make it similar to the one above, so I'm going to make it 0.002. This is a small number which obviously is multiplied by a small number to give me 0.002, not something as big as 10,000. I can rewrite that as 2 times, it's actually, if I divide that by 1,000, I would get, if I take 2 and divide it by 1,000 is how I get 0.002. So I'll rewrite that as 2 times 1 over 1,000, which is really 2 times 1 over 10 to the third, which is really 2 times 10 to the negative 3, and in scientific notation form that'll be 2 times 10 to the negative 3. So the scientific notation form of this number 0.002 is 2 times some power of 10 with a negative exponent, because it was really a small number that I started off with. So this is a lot of work to go through to get the scientific notation form of a number. There's an easy way to remember how to do this, but you basically keep track of powers of 10, and if it's a large number per se, you'll have a positive exponent of 10, and it's a small number per se, you'll have a negative exponent of power of 10. So the scientific notation form is basically a number which is between 1 and 10, smaller than 1, bigger than 1 and smaller than 10, times 10 raised to some power, which is basically an integer. It could be negative number or positive number or maybe even 0. So you basically have a number times 10 to some power, like we did here and like we did here. A number between 1 and 10, it could have decimals, times 10 to some power. And again, this is where it comes from. You break up the number into powers of 10, but there's really an easy way to take numbers and put them in scientific notation. So let's put this number in scientific notation. It's a large number with many digits, and we start at the end and we see how many times I move the decimal length until I get to a number that's between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is where I stopped. And that's going to give me a power of 10 to the 9th for my number. That's going to translate into 3.461 times 10 to the 9th. So if I look at this number in scientific notation form, it's basically 3.461 times 10 to the 9th. And again, you stop when you reach a number between 1 and 10, and the power comes from how many spaces you tracked. So this is the scientific notation version of this number. Okay, again, let's put this in scientific notation. So the invisible decimal is at the end. I'm going to take that and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I'm at 13.6, but I need to keep going. 13. I move 13 spaces. That must be there's a power of 10 to the 13 that's involved. So I have 1.36 times 10 to the 13th as the scientific notation version of this number with this long string of digits. Okay, let's take this small, rather small number and put it in scientific notation. I clearly see the decimal is right there, and the numbers where you don't see a decimal, of course, it's always at the very end. So I keep track of 1, 2, 3, 4, or actually, I went too far. Remember, I need to reach a number between 1 and 10. So I take my decimal and go 1, 2, that's good enough. I went 2 spaces, and I have 1.346. So I have to create a number again that's between 1 and 10. Times 10 to the not 2, because I started off with a smaller number, so I should have powers that are negative powers of 10. To the -2, because I went 2 spaces. And again, if you take your calculator and you evaluate this, it's going to be 1.346 times 1 over 10 squared, which is really 100, so you're looking at dividing 1.346 by 100, and that's going to push back the decimal and get you back to this number. Okay, let's take this number and put it in scientific notation so I clearly see where the decimal is. I start moving it and keep track of stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces is how much I moved, and I ended up with a number between 1 and 10, so that's 2.55 times 10 to the, I moved 12 spaces, but remember it was a very small number, so I must not be multiplying by positive powers of 10, but negative powers of 10, which is actually really dividing by big numbers. 12 spaces, -12 is the number in scientific notation. So, and you know, sort of a way to remember it is if you have really small numbers in scientific notation, they have negative exponents. If you have really large numbers in scientific notation, they have positive exponents. Some people memorize it as, you know, if I move to the left, it's really a big exponent positive. If I move to the right, then the exponent is negative. But memorizing too much will cause trouble because we go back and do the reverse of what we're doing here shortly. Alright, let's put this number in regular form. So I'm starting with 5.61 times 10 to the 7, which means I'm going to end up with a fairly large number. So 5.61 and 7 is 7 spaces to make number bigger because it's a positive power of 10. So to make this number bigger, I'm going to go 1, 2, 3, 4, 5, 6, 7. 7 spaces to the right, and fill those spaces with zeros, because remember you're basically multiplying by a power of 10. So the number in regular form must have been 561, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 zeros. So I was looking at 56,100,000 is what I was dealing with when this number was given to me in scientific notation. Okay, again, I'm looking at 1.11 times 10 to the 4th, so this is spaces to make, again, number bigger. So I start with 1.11, and then I have to make this number bigger by multiplying it by a power of 10. 1, 2, 3, 4 is how many I move. And since I multiplied it by a power of 10, I fill this with zeros, and I end up with 1, 1, 1, 1, 2. So I was really looking at 11,100. Okay, this number in scientific notation, remember it's times a power of 10, and it's a negative number. So these are the spaces to make number not bigger but smaller. Again, I'm dealing with a negative power of 10, which means I'm really dividing this guy by 10 to the power of 5. So I start with 3.621, and I need to make this number smaller because my power of 10 is negative, and I move 5 spaces, so I go 1, 2, 3, 4, 5. That's how many spaces I go to make the number smaller, because remember I'm dividing by a power of 10. Fill those guys in with zeros, so my number must have been 0.00003621. This must have been the original number to give me the number in scientific notation of this form. Last one, put this in regular form. Again, this is the spaces I need to move to make number smaller, again, because I am dividing by powers of 10 because of that negative exponent. So I start with 4.6, and then I move 9 spaces to the left to make it smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I fill those guys in with zeros. So the number I must have started off with originally was 0.12345678446 was the original number. So again, the goal is take a long string of digits and put it in a more manageable form is what we're dealing with here. On your calculator, sometimes you see numbers in scientific notation, and you'll see something like maybe 3.650000, and then at the top you'll see something like 13 on the calculator. It depends on what kind of a calculator you have, and that'll basically signify that you have 3.65 times 10 to the 13. Or sometimes you see 3.65 and then you'll see a bunch of zeros, or you'll just see 3.65e13. Some calculators have that, and when you see that, that really means it's that big number 3.65 times 10 to the 13th. So there's different ways. You may not see this x representation or times representation on your calculator, so sometimes you may punch something in that you expect to be a huge number, and then you see 3.65, and if that doesn't make sense to you, look further. There might be something indicating that it's actually that large number with a positive power of 10, or maybe a really tiny number with a small power of 10.